Hi, and welcome to this information security course on web application security. I am Kamwa Maxey, an information security enthusiast from AIC Expert. This course is divided into two parts. In part one of this course, you are going to learn the basics of web application. You are also going to learn about web application vulnerability and how web application security is important to you and your business. Also, I will be introducing our lab environment to you, where I will show you the tools and the frameworks we'll be using throughout this course. Then in part 2 of the course, we are going to focus on the 5 most common web application vulnerabilities and how to prevent them. The first one is I'm going to show you how to detect if your web application has a firewall or not. The web application firewall is the first level of security for every web application because it helps the web application to mitigate or to prevent attacks such as the denial of service attack and the distributed denial of service attack. Then we'll look at the man-in-the-middle attack, which is one of the most prevalent attacks in recent times. Also, we'll look at the cross-site request forgery, which is a way that attackers use to lure a user to visiting their own site in an attempt to steal their login credentials and other information. Then we'll look at IDOR, the insecure direct object reference, which is a flaw in most web applications that permits a user to indirectly reference parameters or access pages by manipulating parameters in the uniform resource locator. Then finally, we are going to look at the HTML injection. HTML means the hypertext markup language. It's actually known as the language of the web because almost every web application you find today has a little bit of HTML in it. Generally speaking, a web application or a web app has a client to server architecture. And what this means is this: a web application is a computer program that is hosted on a web server, and it can be accessed by users through a web browser. That means if a user wants to access a service or a web application like Google or Facebook, what they will need to do is to type the address of the web server hosting that web application in the address bar of their web browser. For instance, www.google.com or www.facebook.com. A web application vulnerability or a website vulnerability is a defect that is present in a web application due to misconfiguration of the web server hosting the web application, or as a result of an improper input validation in forms, or as a result of a flaw in the source code of the web application. Today, we have so many programs known as bug bounty programs where companies invite ethical hackers and penetration testers to test their apps for known vulnerabilities. And if they get to find any vulnerability in their application and proof that that vulnerability is actually present in their application, they are awarded for it. Examples of such vulnerabilities include cross-site scripting, insecure direct object reference, structured queried language injection, cross-site request forgery, man-in-the-middle attack, remote file inclusion, local file inclusion, denial of service attack, distributed denial of service attack, invalidated input as we mentioned above, broken authentication, and session management. We have seen what web application vulnerability is all about. Web application security now is that branch of information security that seeks to address those vulnerabilities present in web application. That is, it's a branch that focuses more with the security of web application, the web services, and websites. Here you will find the tools and the framework that we will be using for the subsequent portion of this course. We'll be using Kali Linux. We'll also use the Windows 7 as our victim machine. Metasploitable is a tool that's a broken web application that comes with so many vulnerabilities. We'll also make use of the Beef framework, where we'll be launching most of the attacks in Kali. And then all these machines, all these frameworks will be hosted on a virtual machine in VBox. Let's now look at the common web application vulnerabilities and the method of mitigation. We will begin by looking at the web application firewall detection with the tool WAFWolf. WAFWolf is a tool that comes in handy with a Kali Linux operating system and enables penetration testers to check if a web application is running behind a firewall or not. Generally speaking, web application firewall sits in between the internet and the web server that is hosting your web application. So all the requests that are coming in from the clients through the internet to your web server needs to go through the web application firewall first before reaching your server. And based on the policy or the rules set by the firewall will determine which traffic will reach your web application firewall or your application server and which requests will be dropped. Like I already mentioned in the beginning of this course, having a web application firewall is going to mitigate attacks such as the denial of service and the distributed denial of service attacks. And the goal of such attacks is to actually prevent other users from accessing the service that is being hosted on your server by sending multiple requests than your server can process. And that will lead to your server shutting down because it cannot process more than what it can offer. So we are going to be checking some few web applications if they are running behind a web application firewall. So first thing you want to do is to open your terminal, and generally the tool or the framework that we use for the test is the WAF framework. So you can just type the WAF if it's installed. If the package is already installed, you can do WAF or you press enter. So they will show you the general syntax. This is the general syntax of the command. You do WAF and then you enter the command. You can check for multiple sites at once using the WAF and then you enter the URL. That's the link to the site. So we'll be checking the link. So we'll be checking on this site. Let's check this one, www.sodea.org. We want to see if this website is actually running behind a web application firewall. So we'll press enter and we'll wait for I think our connection is down. Let's try again. Let's do an enter. So it's checking actually now to see if that web application is running behind a firewall. So let's be patient, and the feedback we get is that this site is behind a mode security. So there's some sort of a web application firewall present in that. So we'll check for this other site. Let's check for this other site, which I'm also managing, my easy school, myeasyschool.com. So we want to check also if this web application is running behind a web application firewall. So we'll just do press enter and see. For some reasons I have a slow network connection, so you just bear with me. Let's retry again and be patient for the results. So it's actually checking, it's scanning the web application to see if there's a web application firewall present, and we'll just wait to see. Now I said in along the line that the web application firewall actually helps to stop does it we get the response. Now they said the site seems to be behind a web application firewall or some sort of security solution. There we go. Now, like I was saying, the web application firewall actually helps to prevent the site from attacks such as distributed denial of service and denial of service attacks. Let's now look at the man in the middle attack and how it works. The man in the middle attack basically is an attack that occurs when an attacker inserts himself in between a user or a victim and the web application. And the main goal of the attack is to steal private information such as login credentials and private bank information. To fully understand how this attack functions, we're going to look at the following diagram in the next slide. Now, layer 3 communication is done using IP address. At the level of layer 2, communication is done using MAC address. So, for every local area network, for a machine to be able to communicate with another machine in that same network, the two machines should know their IP addresses and their MAC addresses, even though IP addresses is not really important here. So there's a protocol we call the AROP protocol, which is the address resolution protocol, which maps MAC addresses to IP addresses. So if host A, which is the attacker, wants to communicate with the machine that has the IP address 10.0.0.2, what will happen is this: the machine host A knows the IP address of the destination machine, but it is not aware of the MAC address. So it is going to send a broadcast, it's going to send a message to the switch, and the switch is going to send out a broadcast to all its ports asking like, hey, who is 10.0.0.2? So while all the other machines will check to see if it is about their own IP, they all will drop it, knowing that it is not their IP address that was mentioned in that packet. While the 10.0.0.2 will pick up that packet and say, hey, I am 10.0.0.2 and this is my MAC address. So the host is going to forward his MAC address to host A, and then now host A will now use that MAC address and send the packet he wanted to send to that destination host. Back to our diagram on the man in the middle attack. So when during normal communication, the client and the server had already established the connection and there's data in transit. While in the man in the middle attack, what happens is this: the attacker forges or clones his MAC address to look exactly like the MAC address of the client in question. And now the server on its part will think that no, this attacker is the genuine client. So instead of sending the request from the client to the client, it's instead going to forward all the traffics to the man in the middle, hoping that he is having the same MAC address as the one that initiated the connection. Whereas the man in the middle will be now manipulating the data sent before sending it to the client. Hi and welcome back. So we'll be looking at the man in the middle attack and how it works. So in this phase of the course, we'll be making use of the BIF framework, which is actually an exploitation tool that comes with Kali. This is it here, the BIF. Let's launch it. We'll be making use of the BIF framework, and also we'll be launching the man in the middle attack, through which we'll be sniffing into the victim's machine in order to see what they will be doing. So let's go straight away to our command line and launch. Let's go to our command line. So the first thing we want to do is to check our own IP address by using ifconfig command. So our address is the 42.60, and while the gateway is the 42, our gateway will be the .42. So this is the BIF framework. It comes with a UI, a user interface, a graphical user interface that can be accessed through the web browser. And by default, the username is the root, and our password is a BIF. So it is authenticating the credentials to be sure that actually that is okay. So now we are into the BIF framework, and let's just be patient for it to load. I'm actually running multiple instances of virtual machines, so it's going to take a while for it. So this is here, we are right into the BIF framework, and right now if you look here, you'll see offline browsers, unknown, and online browsers. Actually, I've been using BIF framework for some time, and these are some of the previous instances that I was carrying out before now, so I could actually test the framework before I come directly to do the live testing with you guys. So let's go back to our command line. Our IP address here is the 42.60, and our gateway, I also said that the gateway of every network is the .1 is usually the first subnet in that, the .1 address in that subnet. So we are going to use the man in the middle framework. So we'll use the man in the middle framework, and what we want to do is actually to spoof ARP to change our MAC address to the MAC address of the target. So in this case we'll be using the Windows machine, the Windows virtual machine, as our target. So what we'll need to do is to verify their IP address. Let's check their IP address. We'll do an IP config to get their IP address. Let's see. So the IP address, this one is a 42.199 IP host, the .199 host. So we'll go back to our Kali. So we'll do man in the middle framework. So we want to spoof their address, their MAC address. So we'll have ARP, and then we'll have spoof, and then the gateway. We need to enter the gateway of our network, the network gateway, which is the IP address that takes us out of our network. So the gateway is the 192.168. Let's check, is .42.1. And then we need to specify the target. We need to specify our target, which in this case is the Windows machine. So the target is our target is the 192.168.42.199. so that's our target. And also we have to specify the interface, which in this case is I. So we go back, the interface is the Ethernet, the F0 interface, which is the Ethernet interface. So we'll just type F0 and then we'll press enter. So while we are waiting for that to, while we are launching the man in the middle framework, let's go back to the beef framework. If you look at the beef framework here, to use the beef framework here, this is the general syntax. Let me scroll up so you see here. Now the hook, there is a script that we need to inject in order to have access, full access to the client, that's the victim, to have full access to the victim's web browser. And this is the line of code here that we need to inject. We need to type, we need to include this address into the script where the web application will be hosted. So we are going to go back here to the command line. We'll stop the the man in the middle framework first. Then we are going to do we are going to inject that script. So we'll do this. We'll go back here, then we'll inject the script. We inject the script using let's inject the script. The command is js url, and then we'll enter the address here. So it's the IP address. Now it will be the IP address of our host machine, which is the Kali. So we'll have the 192.168.42. Let's check. We first of all verify the previous time is it was the 42.60. Yeah, 42.60. And then the slash the hook just the JS file. This JavaScript file actually is going to grant us access to our victim's web browser. So we'll have full access to the browser to control the browser from whatever thing that they are doing. So let me just minimize this space so you see it clearly. So this is what the command says. This is what the command says. Let me expand this window so you see clearly. So we have basically, we are using the man in the middle framework to spoof their MAC address, which is the MAC address of the target, using ARP protocol. Remember we said that the ARP protocol is a protocol in layer 2 that maps every MAC address to an IP address and vice versa. In the other case, we use the reverse address resolution protocol. So we are spoofing the MAC address of this target, which is the Windows machine, and our gateway, passing through this gateway, and then we are attaching this .js file here, this hook.js, to have full control of the client's browser. So just do enter. So let's wait and see. The man in the middle framework has started. So while we are waiting, let's see what is there. Okay, now let's go back. Let's check the other the window for, we had two windows here. The B framework was already running. Okay, this is the window for the B framework, and as you can see, let's go down. So the B framework is already running because we already had access to the web portal. This is the web portal. So as soon as we are able to connect to the client's machine, we'll be notified here when the client will be online. So there's one more thing we need to do. We have to start the Apache server. The Apache server, because the B framework on itself is going to serve as our web server. So all the requests that will be sent to the client will be sent from us. So we are kind of hosting our own site. We'll be controlling the victim from our own web application or from our own application that is hosted in our server. So we're gonna open a new window. Let's go back here, and we'll do to run the Apache server is we'll use the command service apache 2 start. So that command is going to start our Apache server and ensure that the server is running. So we want to go now to where the home page of our web server is residing, and do some modifications. So we'll go to files, my machine is a little bit slow because it's actually I'm running multiple instances on a virtual machine, so you just have to bear with me, please. So we'll go to files, we will go to other locations where we have the web server directory. So we'll go to we'll go to var, we'll go to www, we'll go to the HTML folder, and the file is residing in this directory. So we'll just open the terminal here and see if we can edit the file that was attached to control the web browser of the victim. So now that we are in the terminal, let's do an ls to list all the files in that. So we have this index.html. So we'll just do nano index.html. We want to edit the IP address to check if everything is okay. Nano. So we have the file here. The file is open. So this is the source. The source here should be this source here. The IP address you see here is not within our subnet. So we have to change this IP address to be the source address of our Kali, because it's actually the B framework is actually running the web server. So when we send this link to the user, this is the link we are going to send to the user, and once they connect to this site, they will be able to have full control to their website. We are going to have full control to their web browser. So we're gonna change this. We'll do let's go here. So the address of our Kali machine is the 192.168.40. I think the 199. Let's check. Let's go back and check. To be sure. Okay, the 42.60 rather. The 42.60. So right here we have .60. So we press Control O, Control X. So we've edited the file, and let's close this window and go back now to the victim's machine, which is the Windows machine, and open our web browser and type that IP address of that Kali machine. So it will be 192.168.42.60. So let's see. So this is our victims machine. Once we point them, they will be able to connect to our machine, to our web server, like the site that we are locally hosting. Let's wait and see, please. Even though it's slow, let's hope that we are able to demonstrate this right now. So let's check from here and see. I'm seeing some results here. So we are already getting some responses that we are already getting some responses from the man in the middle attack. We are receiving traffic from 168.42.60, which is actually the IP address of our Windows machine. So we are getting some responses already. The traffic is originating from 192.168 to this, and the request is being sent to our web server. So let's wait and see. Let's go back to our victims machine. Hey, welcome to my hacking page. So that's it, there they go. So from our Kali machine, which is the hacker's machine, it's possible to do whatever attack that we want to do. We can launch an attack, either a cross-site request forgery attack. We can do whatever thing we want to do from this Kali machine. So let's see, let's have a look. So going by this, let's go back to our B framework. So right now, let's refresh our page. We should be able to see that the Windows machine is online. If not, we will not be able to perform any. So I am still waiting to see that the machine is online. It is not. So I think we'll just have to restart the B framework. So just give me some minute. Let me restart our B framework. Let's close it here. Okay, so let's while we are waiting for, let's see, let's close this one. We are done here. So let's relaunch our B framework. Okay, so while we are waiting for our B framework to open, let's go back and make sure that we still have connection with the victim machine. So we'll just try to refresh and see if we have any feedback. Let's see. Yes, we do have. So we'll just go again and refresh to be sure that we are receiving. Yeah, okay. Now our B framework, the UI interface, the user interface of the B framework is being okay, and we are in, but we don't yet have any active user. We're supposed to have an active user here. Let's see, it should be a connection problem. We should be having a connection problem. Just be patient with me while I see how to resolve this. We are having a connection issue because we're supposed to have access online browser. So let's be patient, please. Let's be patient while I try to resolve this. So guys, I just had to figure out the problem. We made an error in the entering of the IP address of the Kali machine, which is our attacker's machine. It's supposed to be, their IP is 42, not 40. So we just need to save it now. Control O, Control X. So we've saved it. Now let's go back to our B framework and refresh to see if actually there's any active user. And then we do same for the Windows machine. Let's go back and refresh our browser to see. Okay, let's check to see if we are able to see the browser, and there we go. Now we see the IP address. We have 192.168.42.60. Now this shows that we have an active session here because we can access the Windows machine. Let's go back here. You see something? This is the Windows machine right here, and it's accessing our Kali. We have full access. we have full access to the web browser, because whatsoever they do here, we are going to monitor them now from the Kali machine. So let's go to this browser and see. Let's go here. This is the browser right here. Okay, and from here I wish I could zoom this so you see clearly. So from here we can go to commands and try to launch some of the basic commands. Now take note, you need to take note of the page where the user currently is surfing. It's on our home page of the vulnerable website that we are hosting on our Kali machine, which is the hey, welcome to my hacking page. So let's go back to Kali, the B framework. So we want to launch, let's say, actually this is a man in the middle attack. So we want to steal, let's say we want to see credentials, locking credentials from those users. And what we want to do now is to prompt them that their time with the server is up. So we want them to enter we want to lure them or trick them to enter their username and password so we can copy and use them for our subsequent attack. So let's just do let's say pretty tips. Let's use pretty tips. So let's go to pretty tips. So now let's assume that they were surfing, let's say Facebook. So we want to prompt them that their session with Facebook has expired. So we want them to enter their credentials, and then from there we'll have to look them. So we are going to send let's say we are going to execute this command. Let's execute the command and go back here and see what will happen. The user there, which is the victim machine, has been prompted to enter. They said the Facebook session timed out. The session has timed out due to inactivity. So it is prompting the user now, who is the victim, to enter their email and password again. So let's assume that the user goes ahead and enter, let's say, enter their email address, or let's use my email at abc.com, and let's say password, we use password, and let's say let's log in, let's send the credentials. Okay, now let's go back to here and see what is happening here. Right here we see date, we see ID. Let's look at this. You see that we have data. The answer is what? My email. Let me zoom this so we can see. You see that the answer is you look at the credentials that the user just submitted here. It's in plain text. We have my email address at abc.com and the password in plain text. We can also decide to redirect the users, let's say, to another page that looks like let's assume that we want to redirect them to a page like, let's say, Twitter or LinkedIn or YouTube. So in this case, let's use YouTube. So we execute the command, we go back to the Windows machine and see what will happen. So they have been prompted again that their session has expired, they should relog in. Or we could also use let's say we want to use something like LinkedIn. For instance, we want the look to be like that of LinkedIn. We can also use this command, we execute, we go back to the victim's machine, and we have the same issue. So this is how the man in the middle attack works, and this is how you can simulate or emulate the attack in a real life scenario. Also, let's say we want to redirect the users to another page. Let's try to redirect them to another page. So we want to redirect them to another page. Let's say we want to redirect them to google.com. So we'll just enter, we just need to enter the IP address. We'll go to google.com. Let's redirect them to google.com. So let's execute the command. Let's go back and see what happens in their browser. So it's actually redirecting the user, which is the victim, to google.com. So guys, this is how man in the middle attack works, and this is how it can be used. Cross-site request forgery occurs when an attacker tries to trick a victim to visiting a malicious website that is controlled by the attacker, which then submits unauthorized data to a targeted site. In principle, this is how this works. The attacker forges a request for an email change to a website or might even prompt the user in their browser telling them that their session with the server had timed out. So the victim in effect will try to relog in or maybe visit the site, the link that was shared. And when they open the link, the malicious payload on that site will be loaded and submitted directly to the targeted site without the knowledge of the victim, but the targeted site will know that it is the victim in effect that is submitting that request. So the request will be accepted and processed as legit user request. The insecure direct object reference vulnerability is a defect in web application in which a user is able to access and make changes to other users' information on the website. Now, basically, all websites come with an ID, or the pages in a website are referenced using an ID or some sort of tag. Let's assume that in this case, a page to which the current user is connected to is the page having the ID 1000. Now, a smart user who knows, or an attacker who knows that, okay, his or her page is having the ID 1000, might try to alter the ID of that page to something, say 1001 or 1002. And that ID is actually the account, or is actually pointing to the account of another user. Now, a site that is vulnerable to this kind of attack is going to load a page whenever an ID is changed, so long as that user is created already in the database. In the next video, I'm going to show you the demonstration of this attack. The HTML injection attack occurs when an attacker injects malicious scripts such as HTML scripts in a web application in an attempt to get login information or private information and bank account details from a victim. So the victim in effect, when they are pumped up with this interface that looks like those of a well-known site, they are lured into entering their bank credentials or their private information or whatever information that the forms are requesting. And when they do that and submit the information, the attacker now will receive all the information. I'm going to demonstrate how these attacks are launched in the subsequent video. Thank you. Wow, I'm excited and I'm glad to know that you went through this course. Thank you for your kind attention. Please follow us, like and subscribe to our social media channels for more of such contents and updates. On YouTube, please hit the subscribe button. Hit the subscribe button, like and share. You can get us on Twitter at AIC_infosec. On LinkedIn, we are there as AIC Experts. On Facebook, we are there as AIC Expert Infosec, or you can visit our website. Please drop all your questions in the comment box. We look forward to answering them. Thank you.